In the same way we have the A subgroup, we have the weak B subgroup. So a subgroup of B are very rare. So we have more likelihood of finding an A subgroup than a B subgroup. All right. So as we were saying, the subgroup of B are very rare and are much less frequent than the A subgroup. You see that subgroup B are usually recognized by a variation in reaction strength using the anti-B and the anti-AB. Inheritance of B subgroup, similar to that of a majority of the A subgroup, is consequently or is considered the result of the alteration of a allele at the B loci. So for the A, it's at the A loci. For the B, it's at the B loci. Criteria used for the differentiation of the weak B phenomena include the following technique. So we're going to have to look at the strength and type of the agglutination with the anti-serums that are used, usually the ones that we are giving our eye focus on are anti-A and anti-AB. And in that mix, we also use the anti-H. Now we also look at the presence or the absence of the ABO isoagglutinins in the serum. So we need to know if we have isoagglutinins that are present in the patient's serum. So that's give us an idea to where to look. We need to investigate by absorption and elution studies with the B. So the presence of B substances in saliva gives us an indicator, and you must be thinking about this by now. We can use molecular testing to determine the B subgroup. Now, red blood cell demonstrates serological activity for the B subgroup people that are weaker than normal designated B phenotype. All right, so we have the B3, we have the BX, we have the BM, we have the BL phenotype. There are no B subgroup reported that are equivalent to the AN, the AY in the A subgroup category. So a classification system similar to the A subgroup has been used because of the common serological characteristic. So you may remember what we stated for the A subgroups. We're going to use a similar classification for the B subgroups. All right. So serological techniques can be used to characterize a B subgroup into the following category. We have B3, BX, BM, BL. Those are the ones that we're going to be focusing on. The characteristics of each weak subgroup are represented by the following, and we're going to get into those in a little while. All right. So the B3 phenotype generally results from an inheritance of a rare gene at the ABO loci and is characterized by the mixed field pattern of agglutination with the anti-B and the anti-AB. Then the BX, we have the BX red blood cell is typically demonstrated and is observed with the weak agglutination of anti-A, not anti-A because this is a B, so it's anti-B and anti-AB. And then we have other variations, the BM. So the BM red blood cells are characteristically unagglutinated by anti-B and anti-AB. But the BM red blood cell easily absorb and eludes the anti-B. All right, so let us just bear that in mind so that we can have a better appreciation as we move forward. But did we mention the BL? In the BL, red blood cells are unagglutinated by the anti-B or the anti-AB antisera. All right, this is extremely rare. So this is a rare phenotype and must be determined by absorption and elution of anti-B. So no glycosyl transferase has been identified in the serum of serum or RBC membrane of the BL individuals. So BL is inherited as a unique mutation in the exon 7 of the B gene at the ABO locus. Simple. Now, let us get into creating our flowchart so that we can have a better appreciation for the B phenotype. So, characteristics. Let's put it. So, characteristics of B phenotype. So, we're going to list the phenotype. So we have the phenotype. The next thing we want to do is to determine which reagents will react with this phenotype. Then we want to know about the antibodies in the serum. All right, so let's bring it down. For the reaction of the reagents, we want to think about the anti-A, anti-B, anti-AB, and anti-H. All right. Then we want to determine if this reaction is common and unexpected. All right. Now let's start with the B. A regular B individual. We're expecting no reaction in the A. We're expecting a 4+ reaction or a strong reaction in the B, a strong reaction in the AB. And for the anti-H, we're expecting about a 2+ reaction in the anti-H. And when it comes on to antibodies in the serum, we are going to be expecting there to be anti-A. All right. Not only that, when it comes on to unexpected, this one we're going to select none. All right. Now that is the regular B. So this can be our framework as to what is a normal reaction to expect. Now let us move to the B3. So with the B3, we're going to have no reaction with the A, anti-A, but when it comes on to the B, we're going to have a positive reaction, but it's going to be mixed field usually. And then for the AB, we're going to have a positive reaction and it's going to be mixed field, the same kind of reaction that we got in the B. And for the anti-H, we're going to have a 3+. In circulation, we're going to have anti-A, and we're not going to consider any to be unexpected. So that there concludes that section. So the only difference is the mixed field reaction, the positive mixed field reaction in anti-A anti-A, an anti-B, and a higher grade reaction in anti-H. As we will realize with the subgroups, they have a high grade dead reaction with the anti-H. Now, let's go to BX. So when we talk about BX, XXX, we're talking about something that is weak. So there's no reaction taking place in the anti-A, but there's a weak reaction that happens with the anti-B, and an equally weak reaction that happens with the anti-AB. And we expect to get a 3+ reaction approximately with the anti-H. In the circulation, we are going to expect to find anti-A. And unexpected, guess what? We are going to have weak anti-B. So unexpected, this is very important, weak anti-B. So for the BX, we just want to remember that it's weak for the anti-A, anti-B, and we have a 3+ reaction, the anti-H. And because this reaction is weak, we're going to expect some weak, unexpected anti-B to be present in the serum. And what is commonly found is the anti-A. So now let us move to BM. So with the BM, we can have a situation in which, similar to the others, there is no reaction in the anti-A, but as it comes on to the anti-B and the anti-AB, we're going to expect no reaction or a weak reaction to take place. No reaction or a weak reaction. But with the anti-H, we're expecting, as with the other subgroups, a 3+ reaction. Then things kind of go back to normal. So in the serum, we have anti-A, and we have none for the unexpected antibodies in circulation. All right, beautiful. Now let us go to BL. So with BL, this one is a little bit tricky in that for the anti-A, there is no reaction. For the anti-B, no reaction. For the anti-AB, there is still no reaction. But when it comes on to the anti-H, we have a 3+ reaction. All right? When we check the serum antibodies, we are expecting to find anti-A. And when it comes on to unexpected, sometimes we can have a weak anti-B. So sometimes weak anti-B. All right? So this is for us to have a understanding as to the whole matrix of the B phenotype system and their characteristics. So I want you to just remember the operation, and from this operation then we're going to deduce what are the possible outcomes based on the reactions that we get. So when you are in the real world, you will have a ledger, or you'll have a key to guide you as to the interpretations of the various reactions. With that key, you're going to follow the guide, and that will get you to the answers that you so seek to determine about the patient different phenotypes. All right? So now let us do the presence of substance in the saliva, because you know that if we have a secreted gene, there is a possibility that there is antibodies present in saliva. And then we're going to look at the presence of the B transferase in the serum. All right. So those are two things that we're going to look at. We're going to look at the phenotype. Then we're going to look at the substance present in saliva. And then the presence of B transferase in serum. So let's get to it. So for the B person, the substance that we are expecting to find are the B and H. All right. And you'll realize that for all of these subgroups, there is going to be the H, because with the anti-H we had some form of a reaction. The B had straight B had the weakest reaction, which was a 2+, and the others had a 3+ reaction. So all of them we're expecting to find at least the H. So just bear that in mind. All right. And I just want you to wrap your mind around it. The ones that reacted weakly with anti-B and AB, or didn't have a reaction with anti-A and anti-B, those will usually only have H. All right. So just bear that in mind as we proceed. So for the regular B, you have B and H that can be present in the saliva. And when it comes on to B transferase, yes, there is the presence of B transferase in the serum. All right. Now, when we go to B3, we are going to have B and H because we had observed a mixed field plus positive mixed field reaction with anti-A and the anti-AB. All right. So we have that B being present, and sometimes, yes, we will have the B transferase and we'll get a weak positive based on that mixed field that we had, right? Now we move to BX. So with BX, we had a weak reaction in the anti-B and a weak reaction in the anti-AB. In this situation, we're going to have H present because anti-H was 3+. But there is going to be no B in the saliva, and there's going to be no B transferase. All right. So if there's no B in the saliva, no B transferase is observed for this one. Now for BM, we had a situation where there is no to a weak reaction. So in this case, we will have B, and there is a possibility of H, right? Yes, there is going to be B transferase, and this is going to be a weak positive as well, just like the B3, right? And the final one we're going to look at is the BL. With the BL, we are going to observe something similar to the BX, because the BL had no reaction with the anti-B and no reaction with the anti-AB. So what is going to happen is that we had a 3+ reaction with the anti-H. So in the saliva, we can identify anti-H, but because of the nil or the non-reactivity with the other antis that could be identified in the saliva, we will have no B being secreted. And if there's no B being secreted, then there will be no B transferase in the serum. So there is a no. So this is just something that I want you to bear in mind as we continue to examine the different subgroups of the ABO blood group system. So A's have their subgroups. B also has their subgroup. And when we understand these subgroups, it will give us guide as to what to expect when a discrepancy is observed. So understanding the existence of these subgroups and how we can navigate to determine what subgroup it is, when we get the conflicting reaction of the forward and the reverse, then we are in a better position to deduce and determine what is causing the anomaly. And when we know what is causing the anomaly, then we can move into operation to determine how do we resolve this anomaly. Because we have to remember that before we can dispense any blood or blood products, we have to determine what the patient's blood group is and give group specific. If there is a situation where the blood group cannot be determined without the implicated markers, we have to hold off on a transfusion. That is not an emergency. But if it's an emergency, then you know that the routine blood banking procedure would indicate that we give the patient the O negative blood. But depending on the age of the patient, we will give them the group specific blood. So these are just some things that I want you to bear in mind as you continue to peruse the concepts as we seek to understand in whole the ABO blood group system. With that said, class is dismissed.